All right, people, here we go. Second semester applied calculus, and we're getting into calculus now, which is good. We're going to start very visual, is how we're going to kind of go through calculus in this second semester, kind of really seeing how calculus works. The first thing is we're going to be talking about describing functions, okay? And these things here are going to be an important part of it. Um, Let's just go through it. Stuff you've known for years. Domain is what works for X, um, what works or doesn't work, what works for X, and then for range, what works for Y, what Y values are possible, right? So kind of layman's terms here, right? So I always think about like using a stud finder, right? And is it beeping or not, right, over the course. We're going to be using what do we call it? Um, Interval notation, okay, as much as possible, right, as you get ready for the next level. So interval notation. So what works for X, right? I'm going to start here at negative infinity. This arrow implies that it's going forever, both down and to the left. So I'm going to start at negative infinity. Um, and then it goes all the way up until it looks like -2, and there's an asymptote. So I'm going to go negative infinity to -2, and then it's going to start again at -1. So I'm going to do a little U or unite, and then it looks like -1. It starts again, and then that goes continuously again, an arrow here implying that it goes forever in that direction. So there we go. We can't reach positive infinity, so I put a parentheses. -1 is included. We see a filled in dot there, so I'm going to put a bracket there. Okay, so hopefully we're starting to get used to this. What works for Y? So what Y values are in effect, right? So I see this first part, it looks like it's going to be -3 and below. So I'm going to go negative infinity all the way up to -3. I'm going to assume that that's included. Okay. And then up above, it starts at -2, but it doesn't reach -2 because this is an asymptote. So -2, and it goes up to, it looks like, is that 1, 2, 3? It looks like 3. And it looks like 3 is included. I see a little dot there. Cool. So there we go. Domain and range should be easy. Increasing, decreasing, constant. We are always going from left to right. If from left to right it goes up, that is increasing. If from left to right it's going down, it is decreasing. If it is flat like this, we call that constant. Okay? So, starting from the left, we are going up first. So, increasing, we're going to go from negative infinity till about, looks like -4. So negative infinity to -4. I don't really care. I mean, this one definitely we have to do this. On this one, you could include it or not include it. It's kind of up to you. I usually don't include the high point. Um, and then we go down. And then here we're going up. So it's from -1 inclusive. Again, you don't have to do inclusive. I maybe not. I tend to just not because it's not really, I don't know. I don't know. But it's okay. Either way, either one you would put on here, -1 is fine, going all the way up to 1. I typically don't do the endpoints. So that's just how I go. And then the rest is decreasing. So decreasing from -4 to -3, we have a little hole there. So -4 to -3, and then we pick up again at -3 and we go to -2 because there's an asymptote there. We can't reach there. And then one more, we're starting at 1 and going to positive infinity. So 1 all the way to positive infinity. It keeps going down. Um, and there we go. So there's increasing, decreasing, constant. All right, intercepts. Anytime it crosses, we can have an x-intercept anytime it crosses the axis going this way. We have a y-intercept anytime it crosses going this way. Okay, so this one, I see an x-intercept at 2. So x-intercept at x equals 2. And I see a y-intercept at, it looks like positive 2 as well. All right, at y equals 2. You could also have these as points, right? 2 comma 0, 0 comma 2, that's fine. Okay, or just identify where that intercept is in terms of x or y. Cool, 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 cool. All right, all this stuff is like algebra 2, maybe even algebra 1, right? So let's get into some more, at the very least, algebra 2 and pre-calculus-y stuff, but we're going to get to even better stuff here. So holes, are there any holes, right? And we see them right there. So it's along a function that x values that don't count at a function. I like to identify them as points or x values. So a point along function that does not exist, we could say, or that is undefined, undefined, okay? And description in the above example, it looks like the point -3, -4. So I would say hole at -3, comma, -4. Cool. Identify the point itself where the hole is. All right, asymptotes. We have a couple of them here, and we can see them drawn in, right? We have vertical asymptotes. Vertical asymptotes go up and down, right? So we can have those. We can have horizontal asymptotes that can go side to side, and we have slant asymptotes that will go either up or down in this way. You can actually have nonlinear asymptotes, right? So there's all sorts of asymptotes. These are the three that we will see the most. You can cross horizontal. You can cross a slant. You can't cross a vertical asymptote. Okay. So can't, can, and can. Okay. Well, oftentimes you'll see a horizontal asymptote, you'll cross briefly and then come back, or you'll see something that just kind of goes through it sometimes. Vertical asymptotes, you cannot. Okay. It is undefined at that x value. All right. So let's find our asymptotes. We've got horizontal asymptote, and I identify it by by a equation. Y equals, looks like -2. My vertical asymptote is at x equals, it looks like -2. Why are we matchy so much, right? So y equal, or x equals and y equals up there. I know I didn't show it to you. Here we go. Y equals, there we go. X equals -2, there and there. All right, extrema. Okay, so we're going to go um, local max and min. This would be anytime you're at a point, right? And it goes down to the left and to the right of you. A minimum would be you're at a point and it's higher to the left and the right. A global max is the highest point, highest existing point. Okay, a global min is the lowest point in the function. So overall, okay? So I always use this example. Windy Hill behind our school is a local maximum. Okay, but if we look at the entire world, right, it is not the global maximum. The global maximum would be Mount Everest, right? Would be the highest point in the globe, right? So the difference between local. You can have lots of local maxes. There can only be one max, but there doesn't have to exist a max. Okay. So in the problem up above, let's look at local. A local can be a global, right? So let's look at a local max. Do we have any of those? Yes, we do. I'd say right here at this point, that is a max. If I stood on this point, it goes down to the left, down to the right. So at -4, -3, that is a local max. Okay. Up here, we also have a local max. It's also the global max, right? So the highest we can go is 1 comma 3. So I'm going to put that for local, but it's also the global. Okay. So max global is going to be 1 comma 3 as well. We can't get higher than that. Okie dokie. So I put max, both of them for local, but global, there is only one. All right, how about mins? Is there a global min anywhere? And in this case, there is none. None. Okay, local or global. Global means overall, right? So overall, is there a point that is the lowest point? No, because it keeps going forever, right? So we don't have a global. So then I'm looking for anything that just locally is a global. And you might think about this point, but if you stand on this point, yeah, it's higher to this side, but it's not higher to this side. Has to be both, right? We have to have both happening. So we have no minima extrema. All right, end behavior. So this is what happens as x approaches positive infinity and as x approaches negative infinity. We'll be writing this as limits later on. Oops, I should have put that over here. All right, go ahead and put that over there. All right, so for this one, what happens as x goes towards negative infinity? So my left end behavior. So looking over here, let's grab our graph. What happens as we go further and further this way? Oh my gosh, my y values are getting lower and lower, right? So I'm going to say y approaches negative infinity. All right, as x approaches positive infinity, as we go to the right side, what is y getting closer and closer to? Well, let's look at that. Here we go. So as I go further and further this way, what is y values getting closer and closer to? They're getting closer and closer to this asymptote. So y is approaching -2. Y approaches -2. And we'll see a new way to write this as we go along. It'll be using limits, which will be fun as well, but it gets at this idea. So if you understand this, limits will be pretty easy. And that's it. Good job, people. That is your first toolkit of the second semester. Well done. Peace out, Rainbow Trout. We'll see you next time.